In the 1970s and 80s, systems designers began using a technique called object-oriented programming, which was a little counterintuitive for most programmers who were more aligned with thinking sequentially. The fundamental notion behind it was to consider various sections of code as separate objects performing specific functions within a complete software system or program. However, as with most technical skills, descriptions by practitioners or computer scientists were almost incomprehensible to ordinary humans or even ordinary programmers. Despite the apparent complexity, by the 1990s, object-oriented design had become the most accepted approach to systems design. If you are interested in looking at some of the official descriptions, we have engaged with OpenAI's ChatGPT and Microsoft's new Copilot search tool and reproduced their explanations in the accompanying PDF. If you prefer something a little more 20th century, we've also provided a link to an article in Wikipedia. A word of caution though. Failure to understand technical jargon can be hazardous to your self-esteem if you take it too seriously. Often that's the point of complex jargon. In essence, we only borrowed the concept of discrete and autonomous objects from object-oriented design. We use components or data prepared and maintained by others. We call these components objects. Examples might include 1. An online bank account with monthly statements and transactions that can be downloaded. 2. Credit card accounts, primarily maintained by the same banks. 3. Payment processing applications like PayPal, Stripe, Square, Plaid, Zoho Invoice, or 4. Online accounting applications like Xero, QBO, Wave Accounting, Sage. 5. Content management and collaboration systems like Citrix ShareFile, Dropbox, OneDrive, Synology, Google Drive, or 6. Suppliers accounts like Home Depot for contractors, or Amazon for the rest of us. 7. Working paper applications like Caseware or Cloudware. 8. Smartsheet project management software for creating online forms like custom timesheets. We then connect these components or objects into a functional accounting information system, using some key no-code concepts to link them together. According to OpenAI, the no-code approach works in this way. Users without programming backgrounds, such as business analysts, citizen developers, and subject matter experts, can use no-code platforms to create applications tailored to their specific needs. No-code platforms abstract away the complexities of software development, empowering users to focus on solving business problems and innovating without getting bogged down in technical details.
The no-code development approach offers advantages such as faster time to market, increased agility, and greater accessibility to a broader range of users. However, systems may have limitations in terms of customization, scalability, and complexity compared to traditional coding methods. Organizations often choose these approaches based on their specific requirements, resources, and skill sets available.
Both the advantages and disadvantages of no-code development align very well with the situation faced by our smallest businesses. In case we failed to beat you over the head sufficiently with this point, 80% or more of Canada's businesses are made up of the self-employed or employer businesses with fewer than 5 staff. That's about as broad a range of business users as you could imagine. For the overwhelming majority, scalability is not nearly as important as survivability. It's best not to burden them with a complex system until they've grown into it. What's more, the public accountants charged with delivering the final product use these systems for validating the data and suggesting alternatives for tax planning. It is not simply a race to the finish line. In other words, accuracy in testing is important. Even though most of these engagements are simply tax engagements or compilations, it's still important that the results are accurate. In our experience, if you automate a process too effectively, it's hard to examine it critically. It becomes part of what the late Israeli psychologist Daniel Kahneman would call System 1 thinking.